Last week, we covered OpenClaw's security crisis, CVE 2026-25253, malicious skills, the lethal trifecta. But here's the question I kept getting. How did this happen to such a popular project with talented developers? The answer isn't poor programming or bad intentions. It's architecture. 3 critical security skills were missing from the foundation: identity and access management, security-first design, and data quality. Without these, the crisis wasn't just likely, it was inevitable. This video breaks down the architectural gaps that made OpenClaw vulnerable and what that teaches us about building autonomous AI the right way. Let's examine the architecture. The most critical gap in OpenClaw's architecture is identity and access management, what I call Skill 7 in the 9 skills framework. Here's the problem. OpenClaw runs with your user permissions. When you start the agent, it inherits your full system access. If you can read your email, the agent can read your email. If you can delete files, the agent can delete files. If you're an admin, the agent has admin privileges. This violates the principle of least privilege, a fundamental security concept. Systems should only have the minimum permissions needed to do their job, but OpenClaw can't implement this because the agent doesn't have its own identity separate from yours. Real-world example. You want the agent to schedule meetings. That requires calendar write access. But OpenClaw gets that plus your email read access, file system access, code execution permissions, and everything else you can do. The agent needs calendar access. It gets root access. This isn't an implementation bug you can patch. It's an architectural gap. To fix it, OpenClaw would need a complete IAM system, agent identities separate from user identities, role-based access control to limit what each agent can do, permission scoping so agents only access what they need, and an audit trail for what agents actually do. Without agent IAM, every OpenClaw instance is a privilege escalation waiting to happen. The second missing skill is security-first design, Skill 9. This is about building guardrails into the architecture, not bolting them on later. OpenClaw's architecture is trust by default. When a skill requests to read a file, the agent trusts the request. When content suggests an action, the agent trusts the suggestion. When a plugin says it needs certain permissions, the agent grants them. There's no validation layer questioning whether actions are safe. This is the opposite of security-first design, which is skeptical by default. Before executing any action, validate the input. Before granting permissions, verify the need. Before processing external content, sanitize it. Security first means guardrails are part of the architecture, not optional features. Real example. A malicious skill tells OpenClaw to send an email with your private data attached. Security first architecture would ask, does this email make sense? Is this data classification appropriate for external sharing? Is this recipient trusted? But OpenClaw has no such layer. It executes the command. To implement security first, you need input validation for all external content, sandboxing to limit what skills can do, rate limiting to detect and throttle abusive behavior, and kill switches to immediately stop suspicious activity. OpenClaw has none of these because they weren't part of the original architecture. They weren't, we'll add that later features. They were missing from the foundation. The third missing skill is data quality. Skill 6. This is about validating inputs before trusting them. OpenClaw trusts everything it downloads. Skills from the marketplace, content from web searches, suggestions from plugins. There's no validation layer asking, is this information reliable? If a skill gets installed, OpenClaw assumes it's safe. If content gets retrieved, OpenClaw assumes it's accurate. This enables memory poisoning. Malicious actors can inject false information that the agent later recalls as fact. Real example. A skill includes poisoned instructions. OpenClaw installs it without review. The poisoned data enters the agent's memory. Later, when you ask a question, the agent recalls the poisoned information and acts on it. You think it's making decisions based on facts. It's actually using attacker-controlled data. To prevent this, you need source verification to check where data comes from, content validation to ensure data makes sense, grounding to cross-reference against known facts, and provenance tracking to mark verified versus unverified information. OpenClaw has none of these. Here's what validates the 9 skills framework. OpenClaw implemented 3 skills brilliantly: memory management, tool interface, and interoperability. These became their biggest successes. The memory system works. The plugin architecture scales. The platform integrations thrive. But they skipped 3 skills: IAM, security first, and data quality. These became their biggest crises. No access controls, malicious skills, memory poisoning. The correlation is perfect. Skills implemented equals success. Skills skipped equals crisis. This isn't correlation without causation. OpenClaw inadvertently tested the framework at scale. Where they followed it, they succeeded. Where they ignored it, they failed. The framework predicted exactly these outcomes. This proves a key insight. You can't skip essential skills and expect production-ready AI. It's like asking, can I skip the brakes on my car? I just need engine and wheels. Sure, it'll go fast. Once. All 9 skills are essential. Not optional, not nice to have. Essential. So how do you build autonomous AI the right way? Learn from both OpenClaw's successes and failures. Their 3-layer memory architecture? Brilliant. Adopt it. The plugin pattern with skill.md? Excellent. Use it. Multi-platform access? Smart. Implement it when you're ready. But don't skip the security skills. Agent identity isn't optional. Implement IAM from day one with separate agent identities, role-based access control, and permission scoping. Security-first design isn't optional. Build input validation, sandboxing, and guardrails into the architecture, not as afterthoughts. Data quality isn't optional. Validate sources, verify content, track provenance. Use all 9 skills from the start. OpenClaw proved you can build impressive AI agents quickly. They also proved that skipping security skills creates crises. You don't have to choose between capability and safety. You can have both, but only if you use all 9 essential skills. Build deliberately. Deploy when ready, not when fast. That's how you create autonomous AI that's both powerful and secure. If you found this analysis valuable, 3 things will help. First, subscribe to this channel. I break down real-world AI architecture, what works, what fails, and why. The OpenClaw case study is the kind of deep analysis you'll get every week. Second, hit the like button. Understanding AI security at the architectural level helps the entire community build better systems. Third, ring the notification bell. When the next major AI security story breaks, you'll get the architecture analysis that explains the root causes, not just the headlines. OpenClaw's security crisis teaches us that architectural gaps can't be patched. They have to be designed out from the beginning. We covered why missing IAM created privilege escalation, how trust by default architecture enabled malicious skills, why no data quality allowed memory poisoning, and how the 9 skills framework predicted these outcomes. The lesson isn't don't build autonomous AI, it's build it with all essential skills, not just the convenient ones. OpenClaw succeeded brilliantly where it implemented skills and failed critically where it didn't. If you're building autonomous AI, use OpenClaw as a case study. Adopt the memory architecture and plugin patterns, but add the security skills from day one. Your users deserve both power and safety.